Boys and girls, so yesterday we struggled to understand this piece. You're going to write down a few notes that will help you with these problems. We start with this. In which quadrants is sign positive? First and second. Which quadrants is it negative? Now, here's something that's important that you guys missed out on. Where is sine equal to 0? At 0 degrees and at 180 degrees. Where is sine equal to 1? At 90. Where is it equal to negative 1? 270. Okay, so those are some special values that you've kind of forgotten over time. We use them many times, especially when we graph sine and cosine. We started doing our unit circle basics long ago. In which quadrants is cosine positive? First and fourth. So it's negative over here and over here. Now, do you know where cosine is equal to 1? At 0. And it's equal to negative 1 at 180 degrees. Cosine is 0 at 90 and at 270. So these two drawings can really help you understand A, where sine and cosine are positive and negative, but also B, where it's equal to 0, 1, and negative 1. Now, A for the day, who can remember the relationship between tangent, sine, and cosine? Tangent is equal to sine divided by cosine. So watch this. What is a positive divided by a positive? Positive. What is a positive divided by a negative? Negative. What is a negative divided by a negative? Positive. And what is a negative divided by a positive? So you can see why tangent is positive in some and negative in the others. Second of all, let's look at this. What is 0 divided by 1? 0. So tangent is 0 right there. Let's go up to this spot. What is 1 divided by 0? Anything divided by 0 is undefined. Let's go back to this spot. What is 0 divided by negative 1? 0. What is negative 1 divided by 0? Undefined. So you now see very plainly some of the very important values of sine, cosine, and tangent as we're going to solve some equations. Okay? So you're going to reference that from time to time. Okay, let's flip back here. Okay. Oh, come on. Here we go. All right, we're going to pick up with example 11. Okay? So we're going to continue to solve quadratics, but they're going to be a little bit more difficult. So what makes this problem in number 11 more difficult than the other ones? There's two signs. And when there are, we're going to do something that we've done before, but I'm going to show you a problem that's very similar to. 3x squared is equal to 2x. Remember how we solved a problem like that? We'd gather everything on one side instead of equal to 0. 3x squared minus 2x equals 0. Remember how you solve that? You would factor out a x, and you would get 3x minus 2 equals 0. And so you said x is 0, and then you'd solve this and you get 2/3, right? We're going to do the same thing. The difference is instead of an x, I have a sine of x. So we have 3 sine squared of x minus 2 sine of x is equal to 0. I've subtracted them over to one side. What is the common factor I could take out? Sine of x. And when I take out a sine of x, what are you left with here? Three sine of x minus 2. Now I will solve both of these equal to 0. I now have two equations I'm going to solve. Sine of x equals 0 and 3 sine of x minus 2 is equal to 0. This one's easy. Look at your sheet that we just made up. Where is sine of x equal to 0? For what values? Zero degrees, 180 degrees, and 360 would go all the way back around the other side, right? So if we're solving between 0 and 360, we want to include that 360. Let's look at our second one. How do we solve that equal to 0? What do we do to both sides? Add 2. 3 sine of x is equal to 2. Then what? Divide by 3. Sine of x is equal to 2/3. How do we solve sine of x equal to 2/3? We draw a quadrant. Is sine positive or negative? Positive. Which quadrants is sine positive in? 1 and 2. I draw my reference angles. Somebody inverse sine of 2/3 on their calculator. Okay, Eric says 41.8 degrees. We're going to roll with it. Okay, so we're going to count 41.8 degrees, and we're going to subtract that off of 180. We get 138.2. So how many total solutions do I have? 5. Not 1, not 2, not 3, not 4. We have 5. You can't predict by just looking at the equation how many solutions you'll have. It's nice if you can. When we first started this, we would always have 2 solutions. Then we did squareds, and it looked like you would have 4. Well, you know, it's different each time. Okay? So factoring is the technique we're using today. What does it look like you can do to solve number 12? What can you do to both factor out? Factor out a cosine squared, right? And so we get cosine squared of x times what remains? A 1 minus tangent of x. Think if we were to distribute the cosine squared through, what's cosine squared times 1? Cosine squared. And cosine squared times tangent? Cosine squared tangent. So as we distribute it back through, that's what we would get. There's no bad questions. Ask. Okay, excellent. So it came from right here. If I would have had x squared minus x squared y squared, and you wanted to factor that, you take out an x squared for both pieces, right? So x squared times what is x squared? 1. X squared times what is x squared y squared? Y squared. So see, when I distribute it back through, I get this. Same thing with that. Thank you for asking the question. I don't know if I've ever had a year where somebody hasn't asked that question. So a lot of people are probably thinking it. Okay, I set up 2 equations. Cosine squared of x is equal to 0. And 1 minus tangent of x is equal to 0. How do I solve cosine squared equals 0? What do I do to both sides? Square root. Cosine of x is still equal to 0. Oh, hey, we can look at our sheet and see exactly where cosine of x is equal to 0. Very good. 90 degrees and 270 degrees. That's what it says on what we wrote down, right? It says those 2 spots is where cosine is equal to 0. 1 minus tangent of x equals 0. I am going to add the tangent over and get 1 equals tangent of x. Hey, is tangent positive or negative? It's positive. In which quadrants is tangent positive? First and third. Tangent inverse 1. 45. So what is this angle? And what is this angle? 45 plus 180 would be 225. So this one had 4 solutions. Okay, flip it over. Boys and girls. Okay, we're going to try 2 more problems. We're going to switch them just a little bit, okay? So I took these notes from other trig classes I've taught, but the fact is that we want to kind of there's a lot of very difficult trigonometric equations we could solve. We're going to kind of put the level of what we're going to solve. We're going to decide right where that is, and we're not going to do some of these harder ones. We're going to kind of keep it to factoring, and that's where we're going to be. Okay, so same type of situation here. I want to subtract everything over, make it equal to 0. So 3 sine squared of theta minus 4 sine of theta plus 1 is equal to 0. Suppose this looked like 3x squared minus 4x plus 1. Does that factor? What times what is 3x squared? 3x times x. Okay, what times what is 1? 4 negative 1, right? So let's see if minus 1 and minus 1 work. 3x times negative 1. Negative 3x. Negative 1 times x. Negative 3x and negative 1x add to negative 4x. So it factors, doesn't it? Remember our factoring that we reviewed at the beginning? So we will factor this just like we did there. So let's factor it. 3 sine of theta times what will go here? Sine of theta. Okay. Then what numbers go on the end? Minus 1, minus 1. I set both of these equal to 0. Let's try the easy one. Sine of theta minus 1 equals 0, where sine of theta is equal to 1. On our sheets, where is sine of theta equal to 1? Just 90. At 270, it's equal to negative 1. Just 90. Here I have 3 sine of theta minus 1 equals 0. Add the 1, I get 3 sine of theta is equal to 1. Divide by 3. Sine of theta is equal to 1/3. Hey, is sine positive or negative? It's positive. Which quadrant is sine positive in? First and the second. Somebody inverse sine of 1/3 on their calculator? 19.7. So I know 90 is one of my solutions. What's the other one? 19.7. And how do I come up with the last one? Subtract from 180, I get 160.3. So it turns out that this one had 3 solutions. One more? Got it in you? We'll use this space right here. What? All right. Go have fun. See you later. All right, we'll try this one. 6 cosine theta plus 5 equals negative cosine squared of theta. Okay. So you guys tell me, what do you think I should do to both sides? Yep, very good. And I get a cosine squared of theta plus 6 cosine of theta plus 5 is equal to 0. Does that factor? What times what is cosine squared? Cosine times cosine. This is just a regular trinomial. What two numbers multiply to positive 5 and add to positive 6? So we solve. Cosine of theta plus 5 is equal to 0. Cosine of theta plus 1 equals 0. What's the biggest that cosine can be? 1. What's the smallest it can be? Negative 1. Can cosine ever be equal to negative 5? If you try it on your calculator, see what you get. Very good. You get errors. Okay. So we don't have any solution there, but look at our next one. Cosine of theta plus 1 equals 0. That means where is cosine of theta equal to negative 1? 180 degrees. So this one is only one solution. So I'm sorry, I wish I could tell you how many solutions there's going to be each time. And I want you to know, you guys, there are a lot more challenging problems that we can do. We're not going to do them all. We're going to leave it to factoring quadratics. That'll be the extent of what we do. So this is a new assignment. I'm going to pull it from the... Okay, guys, I just have 6 problems. Don't be surprised if you get stuck on any of these. You need to come in for some help. It's almost like we don't have pencils or a website, you know.